In 2003, Shuttle Columbia crashed, and soon after that, the American-owned shuttle program was closed. So since that time, the only way for people to get to orbit is Russian spacecraft Soyuz. According to the agreement, it's always a Russian who is the captain of Soyuz. Soyuz takes people to the orbit and returns them back. And these are the most dangerous parts of all space expeditions. And emergencies happen much more often then. And in time of emergency, it's really important that the communication in the team happens very quickly. Now, all Russian astronauts speak English, but NASA realized that it's not very efficient if the captain needs to think how to phrase a command in a foreign language. It will be best if everything that happens during the way to the orbit and back happens in Russian for the efficiency of communication. And so they go for months and months of training, very considerable human effort, with the only goal to teach Americans Russian language, with the only goal to establish a shared language for communication, for the most efficient communication in the team. Now, the reason I bring this up is because we are speaking now about the shared language. Styleguide-Driven development is the way of working with interface by building a design system as a shared language between designers and developers. We shall look at how to build this language and how to use it. And we'll do it from both perspectives, design and developers. That's why we're two on this stage. I'm a designer, I will talk from my perspective, and Arvid will cover the developer side.
I work as a technical architect. I assemble the teams and set the strategy for how to develop the product. My experience is that the way you structure design work also affects the way you develop the front-end architecture. Even the back-end can be affected by this. What is wrong with the traditional process? What problem are we trying to solve? You receive a screen or a set of screens. You begin with building it element by element. Take one element, pick its style in InVision, for instance. You use Bootstrap or some other standard framework, tweak some parameters to make the appearance of the button match the design. Then you take another element. Again, you style it. If you say similar elements, you will most likely copy the styling parameters to reuse them. But you have not seen the same text label, or if it's 3 months ago, or even 3 screens ago, you most likely don't remember it, that you have made this style. So then you make it once again, and then you end up having a lot of copies of slight variations of the same element. At some point, the user interface of GitHub had 2,449 unique hex codes. That makes interfaces really difficult to maintain. And the color is only one of the parameters you can tweak. The second problem, if a front-end is implemented screen by screen, it can potentially lead to problems with the structure of both the front-end and the back-end. I have seen live examples of the back-end code being more tied into the screens than to reusable services. Another problem. You need to reverse engineer the rules, how these elements are made and laid out on the interface. When you have to derive the rules from the mockups, there is always room for interpretation, no matter how detailed the spec is. This header is 24 pixels from the input below. Is it the header that has 24 pixel padding, or is it the input, or do both have 12 pixels each? We look at another mockup, and here it's not an input, but it's a text right below the header, and the distance is 32 pixels. How did it happen? You need to analyze a lot of screens to reverse engineer each individual rule, like this one. And then you receive another set of screens, and there and there are some values not match the rules you have derived of the previous set, so you need to apply adjustments in these cases. This is a struggle people seldom hear about. Often developers suffer in silence for this. So working like this, we cannot reuse much of the elements we make. The design is messy, and the code base is difficult to maintain, and hard to make changes, and redesign is a real pain. So how can this be changed? Software developers have talked a long time about reusability of code and write once principles. This is often achieved by using patterns in programming, like object-oriented programming you have all heard about. This was first time done by two Norwegians in 1967. They created the first object-oriented programming language, Simula 67. So this pattern is over 50 years old and still going strong. Object-oriented programming allowed developers to define a set of properties and shield the properties with operations. And the developer could give properties and operation meaningful names, as well as hide the internal data structure and business logic from a developer that only need to use the object. Another well-known pattern is MVC, Model View Controller, which describes how data are modeled and how it's viewed and how the data is accessed. By learning and applying patterns, the developers get into well-known ways of how to structure the code, and patterns allow us to recognize the way code is crafted. Style-guide-driven development is also about patterns. It is applying patterns to interface layout. It is creating the interface as a system of reusable components.
Creating a system of reusable components. We'll walk through the changes that are required for this. Step by step, you don't have to go all the way. You will be able to decide yourself at how far your team can and should go. And I will walk through the design side of the changes, and then Arvid will do the same for development side. For designers, supporting style-guide-driven development is first of all a big shift in mind. It means switching from creating like an artist to something much more scientific and predictable. From drawing a nice screen after nice screen after nice screen to establishing a robust architecture of reusable elements. Now, the first step is identifying these elements. We need now to create not a bunch of screens, but something like this. This is a Carbon design system by IBM. We don't see screens here. We see accordions, breadcrumbs, buttons, checkboxes, the elements the screens are and will be made of. And this is what we need to create for our own product if we go this way. And two things that need to be kept in mind here. First, when we start building a design system, when teams start building design systems of their own, they very often jump on creating libraries. Libraries of components, sometimes very big libraries of components. But it's important that what we need is not a set of components, but a system of components. And there's a huge difference here. We need not only to make a library of some elements, but establish a system how exactly we decide what the elements are, how these elements are made, how they are related to each other, and how they are used. We need to identify how exactly to split a monolithic interface into elements. This is one of the most fundamental and actually one of the most difficult tasks when it comes to actual implementation of it. Potentially there can be hundreds of ways how you can split an interface into different parts. We need to break it into the parts that we'll be able to reuse and do it easily. This means that you will always be able to create any new part of the interface using the elements that you have, and also you will not have to adjust them forever for each individual use case. How to achieve this? The approach is surprisingly simple. We need to apply one fundamental principle. What is an interface element in general? It is a piece of functionality that enables a user to do an individual task. So there is a direct relation between a task that the user does and the element that supports it. So to build a system of components, we designers actually need to analyze what tasks the users do in our product. And the smallest tasks are easy to see. So here's some e-commerce website that sells gift cards. And one of the simple tasks that the user may have here is to figure out how expensive the products are. It's not very good resolution here, but we can see the prices by looking at these text labels. So these text labels are the elements that support this task. Understand the price. Now, you may want to see the names of the brands here. And here are other text elements that support this other task. We may want to see how the products look, and here are the images. And all these tasks, see the price, see the brand name, understand how the product looks, all these tasks are the basic, the simplest tasks. They cannot be broken down any further. Therefore, they are the basic tasks, and it's these ones that we are looking for. And these basic tasks are supported by the basic interface elements here. So the basic elements of the interface, the basic elements of a design system are the smallest standalone pieces of functionality that enable a user to accomplish a smallest standalone task. The task has to be as small as possible, but standalone, it has to be not dependent on others. So this is what we are, as designers, need to find in our product, in our interface, and understand by this what are the basic elements in the interface. Now, most often, the smallest step that the user does in the flow are the parts of a bigger tasks, bigger activities. And the same way, the basic elements are often combined into something bigger, like here. And these are also elements, but they are more complex. And these complex elements can also be combined into something yet bigger. There is a green complex element, and there are two more basic elements here in this bigger complex one. So there is some hierarchy here. They are all complex elements, but the level of complexity is different. And there will be different levels of complexity in any interface. And there will be a hierarchy in any interface. And as a community, we are trying to establish the general approach how to handle this complexity, this hierarchy. And the best known is atomic design. The basic elements are called atoms. Combined together, they create molecules. Then there are organisms, templates, and pages. Not everyone is very happy about these names, and they create their own. Not everybody wants to have 5 levels. They want to have less. But this system is as good as any other to start with. Eventually, you will have a system for your own product with as many levels of hierarchy as is needed for the product itself, and it will be dictated by the complexity of the tasks that the users do in the interface. So I said there are two things that we have to keep in mind. First, that we need a system, and second, always comes up when we start discussing this question. Every time we start discussing design systems topic, somebody will ask, why do we need to reinvent the wheel? There already are design systems out there, well planned, outsourced. Why not use Material or any other existing framework? And the visual customization has been made by Google easier than before, so one more hurdle is away. Why not? Yes, visual customization has become easier, but let's look at it not from the visual, but from the structural, from the functional perspective. When we look at any interface, we see that atomic elements are more or less similar in all interfaces here. It's a personal trainer app, some profile, some recruitment portal. They are the same. They may appear slightly different, but the way they work and their structure and their function will be similar. But if we go one level up in complexity, and for example, these cards here in a recipe manager, in a e-commerce app, and in a news app. And we see that yes, all of these are cards, and they support the same task. cards, support a task, evaluate an item. All right, we evaluate items here, here, and here. But the evaluation of a recipe will be very different from evaluation of a pair of shoes or a news article. The content and the context will be different. That's why the elements themselves here are different. They're more product specific than the buttons that I showed on the previous screen. And this is the main limitation of shortcuts like using material or any other existing framework. Unless the tasks that the users do in your product are same or similar that they are in Google, material will always be a compromise. Alex McDuff has summarized it well. Material design works well for Google because it was developed by Google for Google. It was not made for us. So summarizing, first we need a system. Second, it has to be our own system, optimized for your product. This is why we see so many design systems made by leading companies. If we could have used one, we would be able to just create one system and reuse variations of it. No, we have different ones. Each company creates their own. And if we want to go this way, we need to create our own system. So how to approach something that is so complex and so overwhelming? There is good news here. This piece of wisdom is called Gall's Law, and it's older than most of us here. It was written in 1975. And it says that complex systems must evolve from simple systems. You cannot, and you should not, try to build a complex system from scratch. So we must start small, even if we have resources and time and inclination for a big endeavor. We must start with something basic, well-working system. So for design system, it means that starting from atomic elements. Building design system starts by building a system, well-working system of basic elements. In practice, it means that we have to identify what exactly will be the basic elements of our design system of our product, meaning how many of each element we need to have, which elements we need to have, and how many variations and how will they differ from each other. For existing product, we need to identify them, right? And this is necessary even for quite small products that you think you know well. When looking at the product as a whole, it's very difficult to see the real variety of the elements that are made, that this product is made of, to have a good overview, a clear picture of what we have. Like here, you can see that there are 3 small cars, and you can see that they're made of a lot of different elements. But how many elements and what elements you don't see unless you disassemble these cars, leave one element of each on a table, group them together, and then there is some overview here. The same we do with interfaces. The process is called interface audit or interface inventory. We need to take screenshots of pages and screens, cut individual elements, and group them together. Buttons with buttons, list with lists, etc. And then we need to decide, out of all these elements, what exactly do we need in the system? It will hardly be all the elements that you have found in our product. We'll need to minimize and clarify the set that we have. So we are looking at similar looking and behaving elements and try to see if we can substitute several of them with one. The goal is to arrive to the minimal set that will give us enough flexibility to build what we need to build. Like here, from the initial set on the left to arrive to the set on the right. But this smaller set allows us to create the same cars, only they will look more consistent with each other, and also we'll be able to build more cars, and more, and more. As many as we need, as many as we want. So this is what we want to achieve for the interface, to arrive from the buttons on the left to the buttons on the right. Much smaller set that enables us to do what we need. And this we need to do for all basic elements. It can be a long work, but it must be done here. When the product is new, there is nothing to make inventory on. But we need to understand what we need and usually it can be done on a wireframe stage. considering the context and the layout of every page, we come to understand how many different elements we may want to have. And eventually, new product or old products, we need to have an understanding of all the basic building blocks that will build our products, all the elements and all the variations that we need to have. And understanding this for the designers and using only these elements to draw the interfaces from will already be a step towards a more systematic design. Even if we go only this far, it will already be easier for both of us to work together. The next step is understanding what properties define the appearance and the behavior of these elements. What properties front ends need to actually develop these elements. We need to examine each element, like a button here, and then figure out what properties they are defined by. My experience tells that for some designers it's quite an eye-opening task, because we seldom know how many properties are really needed for just a button. This is how many of them there are. And we need to agree on what these properties are together, designers and developers. How we name them, how we call them, the naming conventions. The measurement system, what units we are using and how we measure the elements. And we need again to have this understanding for all types of the elements we are using. The next step is to explicitly write down the values for all properties. Again, this is the work for the designer, quite a boring one, but the one that needs to be done. It's not a big step, but it will allow the developers not to take them from the finished mockups, the values of the elements. Like here, the end values over there. It's a small step, but it allows us to go make the next one, which is much bigger and much more important. Now, we can not only write down the values of the properties themselves, but document the rules how exactly us designers decide which values to give to each properties. How do we decide what color to give to a button? How to decide what size this header should be? How to select the color of the label? We need to document these rules. For a majority of designers, this sounds scary, but the reality is not that bad. When we are drawing the interface, we implicitly assign values. I draw a button and it has color, it has some size, it has some corner, has some radiuses, the text is written some way. So the properties are already there. The only difference is we are trying to make this process more explicit and more structured. And when deciding which color to give to this button, I'm not picking it at random from any infinite number of variations. I select from a limited set. And when selecting from this limited set, I also don't do this at random. I select some color, and every time I select more or less the same color. This set that I have, the values I select from, and how I make these decisions are dictated by my interpretation of the style of the brand that we are making the product for. Now, the difficult part is that first, myself, I can be not very consistent in how I apply the brand style to the actual interface. Today, I'm in this mood, tomorrow I'm in that mood, I've forgotten how I did it last time. I'm not consistent with myself. If there are two designers, the inconsistency grows. And the other problem is that we don't often, or don't ever, document these rules. These rules exist in my head, and it's a complication both for us, for those that try to understand these rules on the other side. They need to reverse engineer this. So what we need is to document this decision-making process and share these rules. Now, this is how we did it for one of my projects. We assigned component-specific variables to the visual properties of the elements. Then we gave global variables to global values here, to the colors in this case. And then I have documented the rules. I did it, in this case I did it like here. Choices I select from on the top. decisions on the bottom. So I select these values out of these ones, and this is how I do it. So these are the rules for these colors, text colors. Now, these rules and the rules for all the things that are all the properties that we have in our interface are the actual style guide for the whole product. The rules how the interface is made, the rules how design decisions are made in my product. It can be, the main point is that they have to be explicitly written down. This is an example of another product or another project where we made a table out of this, and there are also rules here, but written in a different way. The way things are done is not important. The most important thing is that we do document these rules, and it has to be handed over to the other designers and to the developers. And here I have touched only the basic elements. With complex ones, the approach is the same. Identify them, understand by understanding what tasks users do in the interface, in the product, agree on the parameters, and establish the rules how we give the values to these parameters. But as I said, we don't do this before we have the robust system of basic elements, before the system of basic elements has proved to work, both for designers and for the developers.
Yes, implementing a design system should take us from chaos to order. I will walk you through the different states a product can be in and which steps to perform to improve from a given state. The worst state a project can be in is when the style properties are hard-coded all over the place. In this situation that I described in the beginning, when developer picks value from the final design, take an element, find the values, and insert it into the code. This leads to values scattered all over the place. The next logical step is to put all the hex codes into variables and define them globally in the application. Now the colors will not be used as hex codes anymore. Like Tatiana, they refer to the corresponding variable in the actual front-end code. Obviously, this is much easier to change the values when you know where all of them are. Next step is to organize the interface pieces into reusable components. The designer has prepared the styles of some of the buttons, and the developer has put the styles into CSS. Here is the view section of this component. This button can be used many places. The developer do not need to think about styling of each of them, only the first one. Very little work is needed to change the style of all the buttons of the same type throughout the interface. Now we can replace all styling values with variables, like we did with the hex codes previously. Only now we do them in the components too. So in the previous example, the values were hard-coded as shown here. Now we have applied variables instead of. If similar is done throughout the whole set of components, it requires very little work to change the interface. Just tweak the values of each variable in the front end. Next step would be fetching global variables from external source, and in some cases we want to centralize the location of the style files. They become external to the front-end code. This will force the developer to only use defined styles arriving from this external source. And if you have many front-ends or products, they can share the same resources easily. Going even further, we can also implement a stupid front-end. And what do I mean by that? In the previous example, we showed that we use the style variables given from an external source, but the rules of where the different variables are used are kept in the front-end code. By making the frontend stupid, it means that the rules for which colors to use where are moved outside of the frontend itself. Here's an example where the rules are taken away from the frontend. Yes, you see that many of the hex codes are repeated. I started by talking about hex codes everywhere. I've gone through a way to eliminate them, and now I'm getting back into repeated hex codes. So don't worry, this file is auto-generated. Take this line for example, color text gift card title. It tells quite precisely where to use this color. Since this file arrives from elsewhere, the developer do not need to think about why and how this color was chosen. Just insert the variable name in the right place in the code. Later, I will show you how this file was generated. To summarize, now we have looked at 6 stages a product can be in and steps to take to improve from each of these stages. I guess that most of the projects that you have been involved in are somewhere on this line. It is not necessary to go all the steps, it depends. In any case, moving from left to right will help you improve the development speed and quality of the product. We have started using a tool to help us implement a proper design system. We use design tokens. Design tokens are key value variables that store visual design attributes. Design tokens are the single source of truth, the one source to rule them all. In order to be able to centralize the design tokens as well as keep the rules for how to connect the styles to different elements, it's necessary to have a token preprocessor. It will take our hard-coded values along with the rules and provide auto-generated platform-specific implementation files. Amazon Style Dictionary is such tool, allowing us to maintain platform-independent design tokens. The same tokens can be transformed into platform-specific code. These tokens can be maintained either by a front-end developer or a designer. Here you see some JSON files which we use to define the design tokens in this tool. Let's have a look at the fonts.def file. Here is where we define the font sizes. 1 means the size of 16 pixels. And then we can have a look at the fonts file. Here we see different variables. All of them do not have any hard-coded values. They only refer to the previous file. So here are the rules for where we want to apply the different sizes. Now the same for colors. Here is all the colors for this interface. And then we have a look at the text colors JSON file. Shows the rules for where the colors are used. In red here I show the color text gift card title that are mapped to its value. Now let's try to auto-generate platform-specific files. Web, this one you have seen already. iOS, same values, only exported directly to Swift code. And for Android, exported to the Android XML format. All of these are generated from the same source. The stupid frontend allows us to reskin an application like this on different platforms for different partners without touching one single line of frontend code. The changes only happen in the JSON files you saw, altering either the values or the rules or both. And this can even be applied in runtime. Here you see the gift card title is different between these apps implemented in the same SDK with different styles. Now we have saved a lot of work. Now let's go back to this graph. I told you that you could save a lot of work by using style dictionary and design tokens. There is a but here. Let's say you implement some prototypes, then it's not necessary to do more work than you need. You can put the hex codes everywhere. You know you're going to throw away the prototype anyway. At least it seems so. Suddenly someone sells your prototype in a sales meeting and make the potential customer think this product is more or less ready for prime time. The sales guy will then try to push the product forward, and suddenly you are forced to run the proto into some product delivery. If that happens, you might want to start refactoring before the technical debt grows too big. So it's wise to at least do all the parameters in one place if possible. That's a good rule. If you go all the way for a prototype, you most likely have spent too much time on the design system, while the functionality then have taken longer time in the beginning because you have established the design system. So we don't recommend to go this far for a prototype. I mean, here is only maybe for rebranding or for white label applications. You have to sense what is reasonable for just your product and process. You should not overcomplicate the work. The good thing here is that you can take step by step to the right as you go. Gradually improve the design system. Gradually make a system to reduce boilerplate and waste. Gain more control of the look and feel of the application. To summarize all that we have talked about today, let's say if you need to go from point A to B, then you need a car. In Norway, electric cars can drive in bus and taxi lanes. So you will get from point A to point B faster. And they can park cheaper, and the fuel cost is also much lower. And it's a more sustainable model from a global perspective. Yes, you can buy a traditional diesel or gasoline car, and that will serve the purpose, taking you from point A to B, but it does not have the advantages of the electric cars that I have just mentioned. The advantages of Styleguide-driven development are the same. It is faster, cheaper, and more sustainable. Thank you.